Now people say, but if I took all the flavonoids out of the diet, I wouldn't get a deficiency disease. I wouldn't get scurvy, beriberi, plaque, or xerophthalmia, rickets, kwashiorkor, marasmus. So, how do I know that they're useful? We know they're useful because of years of lack of consumption. You will have a rising tide of all chronic diseases that are associated with inflammation.
What I love about Jeff is that he's not someone who's just kind of made a discovery and had a certain perspective and kind of rested on his laurels. He's constantly learning and growing and understanding things in new ways and hoovering up the scientific literature, assimilating it, synthesizing it, and then translating it for us, which is amazing. So without Jeff, I wouldn't have been able to do what I do. I owe my health, my life, and my life's purpose to Jeff. So without you, I don't know what I would be doing. I'd probably be like in a nursing home. So, Jeff, welcome to the Doctor's Pharmacy.
Thank you, Mark. Looking forward to this discussion with great enthusiasm.
Yeah, we've done this before on the podcast, and today I want to dive into a number of topics and have a broad-ranging discussion around some of the emerging concepts in the field of health, nutrition, the immune system, metabolism, and talk about some concepts that really we haven't talked about before. Things like immunometabolism, which I don't even know if I ever heard of before until I started preparing for this podcast, and talk about some of the big contributions of functional medicine that you highlighted in our talk. Now we're here at the annual International Conference for Functional Medicine in Las Vegas. Don't know why we're in Las Vegas exactly, except the Dead are here, and I think some of us wanted to go to the Dead shows at the Sphere. So, in your talk, you did this beautiful summation of what are the kind of seminal contributions of the thinking of functional medicine to the field of medicine and healing that have been made over the last 30 years. And I'd like you to just kind of summarize them and actually just talk a little bit about each one of them. It's GI restoration, metabolic detox, mitochondrial resuscitation, and immuno-rejuvenation. These are four big things that aren't taught in medical school that have profound impact on our health, that are now being recognized as fundamental to most diseases, and especially with the billions of dollars flowing into the longevity research space, we're seeing scientists now discover what they call the hallmarks of aging. What are the fundamental things that go wrong as we age that aren't inevitable, but that are identifications of dysfunction that can be modified and reversed? And so can you maybe just sort of start with the first one, which is the GI restoration as a concept, and maybe give a little history of sort of how this came to be, because you were one of the first people to ever talk about the gut, and we talked about it in functional medicine before there was even a term, the microbiome.
So I think it's really interesting, isn't it, to ask where the origin of ideas come from, because there are very few ideas that came out of nothing. They were built around other perceptions and development of an ideology that some people latched onto, and then they evolved. So when I was sent this cover from a syllabus that I did for a doctor's seminar in 1985, and reminded that I had done a seminar on inflammation focusing on the gut, dysbiosis, leaky gut, and endotoxemia.
Yeah.
I thought to myself, well, I didn't just come up with that. I mean, that was around, and I just embodied that information into that course, and then I took that course around the country and I introduced it to people that had receptive minds to the concept. That concept that the gut plays a principal role goes way, way back to Egyptian medicine, to Galenistic medicine. It has been a fundamental, Hippocratic principle. Disease starts in the gut. It's the foundation of natural medicines of many different cultures. And in fact, the winner of the 1901 Nobel Prize in Medicine and Physiology, who was that?
Eli Metchnikoff.
Bingo, he gets the award for that. So, and what
I'm a good student.
What was his discovery? So Eli Metchnikoff took over the Pasteur Institute for Louis Pasteur when he died. He was obviously a Russian physiologist, and he was imbued heavily in the principle that was emerging in the late 19th century around microbiology. if we think back, that was the age of the microbe was starting to emerge. And so he actually was very, very interested in where the microbe existed in the human. And that time they were doing cultures of stools, and they would find, yeah, there are a lot of microbes in the stools of humans. And so he became very interested in that, ultimately then trying to think of, this is pre-antibiotics, how would you then improve the bacterial colonization? Because remember, bacteria at that point were considered kind of dangerous. They were all bad. But now he's saying, hold on, in healthy people we find these. So there's something going on here about the composition. So then he came to the conclusion that maybe reintroducing bacteria that would be considered healthy bacteria into the guts of the distal portion of the intestinal tract would be beneficial. So he propounded this concept of enemas containing Lactobacillus bulgaricus. A yogurt, it was basically yogurt enemas, basically. And that became part of a book that was translated from the French into English, which I'm very pleased to say in my book collection, I have an original edition called The Prolongation of Life. And it was all around anti-aging. And anti-aging was to restore the friendly bacteria in the gut, and his treatment was yogurt enemas.
Yeah.
Now, this is the guy who won the Nobel Prize in medicine for the discovery of what? The innate immune system. Remember how he did this? He was in the South Seashore. He had his monocle. He had a starfish, and he had a sea urchin. He punctured the starfish with the sea urchin. This is the way the story's told. I don't know if this is totally true. Then he looked with his magnifying glass, and he saw these corpuscles coming to the site of penetration, and he thought, obviously, these must be bacteria, because this is the age we see the thing through the lens of our experience. But then when he studied this more, he said, no, that you couldn't culture these. And then from that, he said these must be big floppy cells, which we now know as white blood cells. So from that was born the innate immune system. That was the first discovery. And then he later started saying, well, maybe these people that are getting these installations of yogurt, maybe it's influencing their immune system. This is way before the term microbiome was coined. But that then rolled forward. So this is like the turn of the 19th to the 20th century. And then you follow that literature in which, I don't know if you're all familiar, but there was a period in American psychiatric medicine at the Trenton Hospital in New Jersey, the largest mental hospital in the country, that was the NIH Center of Excellence for Psychiatric Health. The leader of that particular hospital, of that wing of the psychiatric hospital, so believed in the concept of endotoxemia as an origin of psychiatric diseases that he said the only way you can treat this is by surgical resection of the bowel. So they started taking out portions of the bowel in these patients. And it turned out that they were reporting evidence of people recovering from acute psychiatric illness from getting these surgical treatments. And the NIH was propounding this and was giving funding for the grants to do this work because of these positive data sets. Well, it turned out it was all fabricated. There was a whistleblower that eventually said this information was wrong. In their repository, in their path lab, were all these organs of dead people. And there were hundreds, I don't recall the exact number, but let's just say a lot of deaths that were not reported. And it was basically, they were doing everything as a focal site of infection, pulling out teeth, they were shortening the bowel, they were doing stomach surgeries and all these things as a psychiatric treatment. So what happened in the period of 1930 was the construct of endotoxemia became so alien to medical thought that even to raise that was grounds for expulsion. So it was wiped out entirely. They didn't wipe out the treatment, they wiped out the concept. And so for the next 50 years, it was verboten. You could not discuss this in medical school at all. This was not going to. And so I was naive to all of this, right? I hadn't read the book Madhouse because it hadn't been written at that time. Madhouse is a fantastic book that describes this whole period of history, written by a medical historian from UCSD. And
wow.
that particular story was unknown to me. So I just went into this kind of naively saying, well, hold it, there's something here about Mechnikov, and look at all this other literature that's developing around hepatocellular function. And then later we landed on the 4R program for gastrointestinal restoration, saying, no, hold it, this is real. We don't have to give just enemas from the south up. Maybe we should give it from the north down. Maybe we'll let gravity work in our favor, give it in the mouth by giving the things that the person needs to grow back friendly bugs and to restore gastrointestinal mucosal integrity, because we now recognize there are these paracellular junctions that are becoming leaky, and what are called middle molecular weight molecules are swimming through by passive diffusion into the blood, and now the body's immune system is activated because these are foreigners, and that's what the immune system is supposed to do, is recognize foreigners. So all this became part of this 4R program that we emerged in functional medicine, which was remove the bad stuff, replace...
Bad stuff being?
Well, bugs, infectious organisms, food allergies, toxins.
Yeah.
And then the second R, this is 4 Rs, second R is replace, because we recognize there are a lot of atropic type B hypochlorhydrics, because their parietal cells of the gut are not acidifying the chyme correctly, and once you don't acidify the chyme, it doesn't stimulate the endocrine pancreas to secrete enzymes correctly, or your gallbladder doesn't neutralize with alkaline exudate. So now you have an underdigested material heading down.
For everybody listening in English, that means your stomach acid is low, doesn't activate your enzymes, and so your digestion's messed up.
That's right. Thank you. Very good. This
I
is
told
why,
you I'm the Jeff
why
Bland
we
translator.
worked together well for all these decades. So we started talking about, at that point, and this is another interesting part of history, we started talking about pancreatic insufficiency.
Mm-hmm.
Now, we were heavily criticized,
Yeah.
because the gastroenterology community said, no, hold it. If you have exocrine pancreatic insufficiency, you're going to have severe steatorrhea, you're going to have all these malabsorption
Fatty
syndromes,
stool,
it's
yeah.
going to become very evident, and that's a gallbladder and pancreas problem that requires medical intervention. And we said, well, no, we're not talking about cystic fibrosis and these kinds of very severe issues. We're talking about chronic insufficiency. And actually, we did a study and published it because I asked the question, how much stomach acid would you have to secrete to acidify one steak dinner? Because steak, high in protein, is a very good buffer of pH because of the amino acids, which are buffering. So you have to really acidify a protein-rich meal to get it to be acid when it goes in the duodenum. And so I asked the question, how much acid? We did a calculation of how much would have to be secreted. And then we did the test, and Dr. Jones remembers this, I'm sure. We gave the people the little telemetry device where it could measure gastric pH all the distance of the gut. And we studied a person's GI, and this was with Great Smokies Diagnostic Labs, so this is back in the 80s. And then we used the telemetry device, and then we calculated how much acid. And what we found is that you could have chronic pancreatic insufficiency, which then, if you acidified with betaine hydrochloride and you gave pancreatic enzymes, you could then relieve some of these digestive problems and make that person more compatible. Now, we were very, very heavily criticized. Now, what do we hear on radio and TV ads? It's all about exocrine pancreatic insufficiency. It's now exocrine EPI, right? So everybody now should fill out a questionnaire as to whether they have EPI. Well, we've been talking about this since the 1980s.
I mean, it's true. I mean, you saw stuff coming decades before anybody else saw it. And your associative mind just looks at the patterns and the data across multiple disciplines and sees these relationships that no one else is seeing and no one's talking about. And you're talking about the microbiome being connected to everything now. What's connected to metabolic health, to psychiatric health, to immune health, to pretty much everything you can think of: cancer, heart disease, diabetes, obesity, and now it's mainstream. And now one of the hallmarks of aging is the degradation of the microbiome as a factor that happens as we age. So
let's take that a step farther, because what happens in this digestive process, I stopped at the second R, that's the replace R. The next third R is reinoculate, which is to give the pre and probiotics to restore the healthy bacteria. But we know that there's another part of this system that is very important, which is the liver. And what does the liver do? The liver secretes bile. And where does bile come from? Bile comes from cholesterol that gets converted by a series of enzymatic steps in the liver that requires vitamin C, by the way, and copper, and in terms of that enzyme. And then it produces this family of these bile salts. Now, I always thought in my early years these emulsified fats, so they help to digest and absorb fats. But now we know these are signaling molecules. These bile salts play very important roles in stimulating receptor sites on the surface of our GI tract to release enteroendocrine hormones like GLP-1 and to regulate function far beyond just emulsifying fats. And now there are new drugs for the treatment of NASH that are really bile acid mimetic drugs that are affecting the receptor sites that bile acids influence. With a healthy digestive system, you're doing that naturally. It's not asking for a drug. It's asking to stimulate those receptors to signal correctly. So gastrointestinal health is much more than just what you take in and what you poop out. It's all the business that occurs by these signaling molecules from a healthy digestive system that are intimately communicating with your microbiome, which then, that's the third R, reinoculation. Then the fourth R is to repair, because you have these holy mucosa membranes, you want to repair them, so you have arginine, you've got pantothenic acid, you've got, there's a whole series of things that omega-3 fatty acids and so forth.
Yeah, and the fifth R we added was restore, which is dealing with our stress response. And that model, Jeff, which is a simple method with very clear steps that can be applied generally and effectively, is something that just has not been taught in any medical curriculum. My daughter's in medical school now, and I'm like, do you learn about this or that in microbiome? No, nothing. And it's just astounding to me because it's such a fundamental part of healing people. As you saw through the case presentations that I did, it's really often the place that I start, which is fix the gut, and then everything else sort of tends to get better. And if it doesn't, then you go to the next step. And I think the insight and the wisdom around bringing the ancient sort of knowledge from 1901 back into current medicine, and taking the kind of clinical experience we've all had with repairing the gut and seeing that create profound impact on patients' health is a real revolution. And what's interesting to me is there's all this great research going on in the microbiome, and we're learning so much more, but still the application of that has not been really well formulated by traditional medicine, even though it's now recognized. And I think the functional medicine principle of gut restoration is so key, and it's so simple, and it's these simple steps of remove, replace, reinoculate, repair, and restore. And it's something we teach in the Institute for Functional Medicine. It's not that hard to apply. And it's something that actually the individual can apply out there listening, even without seeing a doctor, by just following the basic simple principles. So it's such an incredible contribution that you've made. I don't think most people know that, if it wasn't for Jeff Bland, we wouldn't be talking about this stuff.
Oh no, we would, Mark.
I don't think so, Jeff.
No, we would. I think I was just a compiler of lots of, but let me give you.
You can be modest, but I don't think, I think you're FOS on this one. And I think that you saw this and you taught it, and you, without even completely understanding it.
I was the only guy willing to travel 6 million miles. So let me give you.
Talked a lot of shit, that's right.
Yeah, that's right. Let me give you a quick example of how this is, to me, just how enlightenment occurs. So I'm invited to University of Copenhagen Medical Center to give a presentation on this very topic to their whole staff, the interns, residents, and senior staff, and nursing staff. And for me, this is a big deal, right? Because this is a center of excellence and really high quality medicine there. And so I was invited actually by the lead nurse, who is the surgical nurse to the head of the department, who was reputed to be the top gastrointestinal surgeon in Denmark at the time. So it was a big deal. So I give the first part of my talk. It's all the big old amphitheater type surgical presentation, and then we have a break and we go into the foyer. And so the woman who's invited me wants to introduce me to her boss. And so I go over there, and she's very polite, introduces me to him, and he's courteous and says, "Oh, nice to have you here. And that was a very interesting presentation you gave. That was half the lecture." And I said, "Thank you." And he said, "But of course, that's everything you said is experimental. There's no proof of this." And I said, well, I know this is early on. We're collecting information from a variety of sources, and that is true. But we've seen many people that have employed this concept in their practice, and they're having success with their patients. Well, I'm sure that's true anecdotally, but you have to look at all safety and all sorts of other variations, and what are typical and atypical, and this has years more studies to be done. So I'm listening and being polite, and he's kind of blowing me off basically, and. So then the woman who's the nurse is standing there, his nurse, and she says, so doctor, she said, well, I can understand your reluctance, but I need to tell you something. Remember my daughter, who you treated for Crohn's disease? Unsuccessfully? And do you remember that she had been your patient, and you had done everything you could, got the best of the medicine here, and yet she was so seriously affected she could not leave the house. She was agoraphobic. She could not go outside, and her life, and she was short to stature for her age. She hadn't gone through menses, and she was 15, and she had all these problems. And I heard this tape from this gentleman, Jeff Bland, and he talked about this program, and I thought, well, gee whiz, doesn't seem like it do any harm. It's elemental diet and the kind of things that I was just describing to everyone. So I decided to try it. And the doctor's surgeon's looking at her, and he goes, so I'd like to introduce you to my daughter, who is this beautiful statuesque woman that steps over, and she says, yes, when I got on the program, for the first time I was able to have normal bowel movements. And this last summer I backpacked with my friends around Europe, and I grew 6 inches, and I have menses, and I attribute it to his program.
Right, yeah. I mean, yeah, it's true. I mean, if this one concept could permeate healthcare, it would be ground-changing for everybody. So, the next big kind of idea you talked about was this concept of metabolic detoxification, and let me dive into that. I don't know if you're referring to detoxification for environmental toxins, or you're talking about insulin resistance, or you're talking about all of it. What are you talking about when you mean metabolic detoxification?
So our body produces a variety of things, waste products from our metabolism that are not necessarily friendly molecules. They are potentially poisonous molecules. I mean, even use one that people are probably familiar with, lactic acid, lactate. We know what happens when we build up lactic acid in our muscles. They become poison, they become sore, and we have to get rid of lactic acid. If you condition yourself, you don't produce as much lactic acid, so you have better endurance. So there are many, many hundreds of different molecules, actually thousands, that our body produces that it has to get rid of. Some of our molecules that are messenger molecules, like hormones, like stress hormone, cortisol, or aldosterone to regulate blood pressure. Or we could think about sex hormones, testosterone and estrogen. All of those have to be eliminated from the body, and because they're fatty substances, they want to stick around in our body. They want to stay in the body. So the body has to convert them into a form that it can get rid of them, generally by the urine or the feces. So it has to make them from a fatty substance into a more of a water-soluble substance. So that is a process built into our physiology. It's genetically conserved over all animals, and it's called detoxification or metabolic conversion.
So it's pooping, peeing, and sweating.
That's right. Get rid of those things. That's right.
And breathing.
So the interesting feature of this process is the principal organ, not the only organ, but a principal organ where this occurs is in the liver. So the liver is a very important organ for taking these things and making them into something else so they can be eliminated. Now, we would just assume that everybody's livers are able to do this just fine. But again, having been introduced to one of David Jones' medical school faculty from the University of California, Davis, who had looked at what happens with people that have alcoholic delirium tremens, what happens to many of those individuals is they lose their detoxifying ability because of hepatocellular injury. And they then lose their detoxifying ability, they become endotoxic, and it produces hallucination and psychosis. Similarly, for hepatic encephalitis. Hepatic encephalitis should really be called gastrointestinal hepatic encephalitis, where the gut is producing toxins, the liver is impaired so it can't detoxify them, and that goes to the brain and produces a toxic relationship. They become hallucinating.
Can you just stop for a second? I just want to translate. So, so for those listening, what Dr. Bland is talking about is something we know really well in medicine. If someone comes in who's an alcoholic and has liver failure, they become crazy because of the bacterial toxins that they can't metabolize. And so the treatment for insanity, essentially, is an antibiotic and a laxative, right? To clear out the gut. And the implications for that have not been really understood as it broadly applies to psychiatric health, but it sort of goes back to the story of Eli Metchnikoff and psychiatric illness. And we now know the microbiome plays a huge role in mental health. And the inability of the body to metabolize or detoxify those metabolites drives mental illness as one of the causes.
Exactly right. Thank you. That was good demytholization of what I was trying to say. So in this case,
not everybody listening out there has a PhD in nutritional biochemistry.
So the key point of this discussion, I think, for takeaway value, is that studies were done showing that these processes that detoxify can be modulated by certain constituents of the diet. Certain foods have the ability to communicate to the liver to, we call it upregulate, or to increase the ability of those detoxification processes to occur. So years ago, this would be now nearly 20 years ago, we invited at the Institute for Functional Medicine a variety of leaders in this field, Talalay, Elizabeth Jeffrey, people who were studying at the fundamental science level of how certain nutrients in foods, like the glucosinolates in cruciferous vegetables, for instance, could then influence the detoxifying capability of the liver to do its work. It was told us at that time that this really didn't play a very important role. This was all just a bunch of intellectual gobbledygook because everybody had more than adequate detoxifying ability. It didn't really depend on how many crucifers they ate in their diet. But actually we found that that was not true because there are actually studies that have been done showing that people who take OTC meds, that the first pass distribution of those meds in metabolism is dependent on whether they had grapefruit juice or they were to have had sauerkraut juice. That's a big one that's been studied. And so these concepts that diet can influence the ability to detoxify drugs means it can also detoxify other things native to the body. Our body doesn't have one pathway for drugs and one pathway for natural stuff. It's the same thing that is used, same mechanism. So we started looking then at this whole array, this panel portfolio of foods that are rich in these nutrients that enhance the function of this so-called phase 1 detoxification and then phase 2, because they're coupled together so we can get these things out of the body properly. And we started measuring using caffeine clearance and benzoate conjugation, certain assessment tools in people to see if you could really do that. And Andy Brawley and I...
Yeah, I love that test. It disappeared, though.
I know it's unfortunate it did, because Andy Brawley and I actually did, this is at Metametrics way back when, did thousands of patients looking at the data and showing, we published a paper in the Journal of Applied Nutrition showing that we could determine a person's capability of detoxifying based upon these surrogate tests.
Yeah.
And so that then ultimately gave rise to us putting that together into a clinical program, which we call Metabolic Detoxification. So there is a dietary intervention program that would improve or support the detoxifying abilities of people who are impaired in their abilities to get rid of these molecules and would build them up in their body and have side effects.
Yeah, I mean, it's so important because not only are we dealing with our own metabolic toxins we have to deal with, but we're dealing with a huge load of environmental toxins that are ever more present. It's probably over 100,000 new to nature molecules since the turn of the last century, and now we're discovering microplastic and nanoplastics in our arteries that lead to the progression of heart attacks and strokes. And so we really have to have some method for understanding detoxification. It's another one of those things we don't learn about in medical school. We don't learn about the microbiome in the gut and how to treat that. We don't learn about how to deal with metabolic or environmental toxins and how to upregulate those pathways. And so that's a huge piece. I mean, for me, as someone who had mercury poisoning and had chronic fatigue from it, I had to learn about detoxification, and I had to learn about what genes I had that impaired my detoxification or that didn't facilitate it. I had to learn about how to look at my load of environmental toxins and how to upregulate those pathways. And doing that with patients is a profoundly effective thing. And I think it's one of the actually real nuggets of functional medicine that I think is sort of underappreciated, but can be widely applied to help people just improve their overall health. The next thing I want to talk about, and I think you left out of your 4 big advances, one which I think we can touch on at the end, which is insulin resistance and metabolic dysfunction. But so the next big contribution is this idea that our mitochondria matter. Now I learned about mitochondria in first year medical school. I learned about the Krebs cycle, biochemistry, but then quickly forgot about it and learned about a few really rare inherited mitochondrial diseases, but otherwise it was kind of an irrelevant topic when it came to clinical medicine. Yep. And yet now we're learning that mitochondria play a role in almost everything, whether it's cancer or obesity or diabetes or dementia or Parkinson's or mental illness. Chris Palmer's work, who's been on the podcast, talks about basically mental health being a metabolic mitochondrial disease. Suzanne Go was on the podcast where she talked about mitochondrial dysfunction in autistic brains and treating that directly. And so you are one of the first to bring mitochondrial medicine into the conversation decades ago. And I was like, well, who's learning about mitochondria? I don't want to learn about the Krebs cycle again. I'm like, this is annoying. It's like, but actually it's one of the most fundamental things. And I actually had to learn about mitochondria also because I had mitochondrial dysfunction. With CPKs of 600, my muscle enzymes were so high, my mitochondria with chronic fatigue were not working. And I had significant mitochondrial dysfunction, and I had to learn about mitochondria in order to actually heal myself and heal my patients. And it's one of the central things that we do in functional medicine is to understand and to treat mitochondrial dysfunction by eliminating the causes and upregulating mitochondrial function. Can you talk about this whole idea? How did it come to be, the mitochondrial resuscitation, rejuvenation idea?
Yeah, thank you. So this is really a fascinating example, I think, of how we taking information and we start assembling it into a kind of a story. So for me, because I had been going to Atlanta quite a bit in the early days of this field, working with Metametrics and then later Great Smokies, I was introduced to this gentleman in Emory Medical School who was in charge of their inborn error metabolism mitochondrial disease unit at the medical school. And I learned about mitochondriopathies from a genetic perspective that we have, because mitochondria have their own DNA, extranuclear DNA, which comes exclusively from the mother. So these are maternally linked genetic disorders, and things like Leber's optic neuropathy are very, very serious conditions for these children to suffer from. And so I was learning about the mitochondria from that kind of pathological perspective. So then we were reintroduced early on with functional medicine to Dr. Paul Cheney and his colleagues at Incline Village, Nevada, who were the first to report this infection that they were seeing in their patients that was called chronic fatigue syndrome. This was during the AIDS HIV period in the mid-'80s. And so we developed a relationship with Paul, and Paul was a PhD in immunology and quantum chemistry, or quantum physics actually, and an internist. And so we kind of really geeked out on this whole concept of why did you see people with this condition after they got over what appeared to be the infection. They still were chronically ill for many, many, sometimes years after having this chronic latent condition, not dissimilar to what we see with long COVID now. And so we started really digging into that. And I give a lot of credit to Scott Rigdon, who was one of our first medical doctor involved. And he, in Tucson, Arizona, in Scottsdale, Arizona, had a lot of chronic fatigue patients. And so we started doing a lot of work with his patients. And that led me then ultimately to what I consider like the moment of an aha. I met Robert Hackman at the University of Oregon, who had been hired to run their nutrition program. He had gotten his PhD from Lucille Hurley at Davis, who was very, very big in zinc and immunity. And so Bob and I got, actually Robert and I got talking about this concept of mitochondrial bioenergetics, the energy powerhouse of the cell, the mitochondria. And he said, yeah, I'm interested in the mitochondria too. And I said, we need to study the mitochondria in human beings to show that there is some different functional state in people that have these fatigue-related symptoms. And he said, well, gee whiz, Jeff, maybe we're lucky because The University of Oregon just got a grant from the Otsuka Corporation in Japan to bring the largest superconducting 5 Tesla magnet to do NMR spectroscopy in whole organisms into this laboratory. We could be the first people to do whole body NMR analysis. And so we developed a piece of equipment where the candidate would put their limb of their body, generally with the arm or the leg, into this machine. It was a goniometer type of instrument within this huge magnet. And then they would exercise, and we would measure the phosphorus 31 resonance. Remember that mitochondria power up ATP, adenosine triphosphate. One of the isotopes of phosphorus is anisotropic, P31, that you can measure with a nuclear magnetic resonance spectrometer.
In English, that means, for those listening, that when you're making energy in your mitochondria, it uses phosphorus to actually make ATP, which is the fuel, the gasoline. And through the basically MRI machine, you could see this particular phosphorus and whether you're producing energy or not.
Exactly. And so we could measure the energy depletion and the energy recharge. So we measured.
I've been doing this my whole life. It's okay.
I'd be nothing without him, obviously. So what can I say? So
I had to hit rewind so many times on my cassette tape that like the tape would break. So, and I actually started to understand Jetblend-Ease. But it took me a while, but now I am fluent.
You got it. You're total fluency. So we took 34 people, apparently healthy. And this particular study was all women. And we put them on a program, which we later called the Mitochondrial Rejuvenation Program, or Resuscitation Program. But it was basically high nutrients that we knew were supportive, like coenzyme Q10, vitamin D, vitamin D, vitamin E, omega-3 fatty acids. What else was in that? Lipoic acid. I think we had NAC in there and N-acetylcysteine. So they were put on this program, and we measured prior to putting them on the program their ATP recharge rate using this technology I just mentioned, where they would exercise to exhaustion in the machine, and we see how fast their ATP would go down and how fast it would recover. And so then we put them on this program for 12 weeks, and then we put them back in the machines and tested them again. And lo and behold, we got extraordinarily fast recharge and much slower loss of energy from their mitochondria. I mean, this was a surrogate measure, but was considered at the time to be the method of choice. Now, an interesting feature of this, which I learned a big story.
So basically what you're saying is you gave people the basic raw materials to make energy, which are vitamins and nutrients and minerals.
That's right.
That actually can produce the energy from food and oxygen in the
More
mitochondria
efficiently.
more effectively, so you get more energy production.
Yep.
And a lot of people are walking around with low energy and fatigue states that may be related to mitochondrial dysfunction. But it's also across all the spectrum of diseases that we just talked about, like mental health to metabolic health to cancer and everything else.
And so their symptoms, their felt state across the board of those women improved. They had more energy, more clarity of thought. You know, we measured them with pen and paper psychometric instruments. So we were so excited about that, and we tried to publish it, but nobody would accept that publication because that technology was so new, and they thought we were making this up. Literally, we ended up in a tertiary journal, finally did publish it. It took a year and a half of testing all sorts of different journals. We finally found one to accept it. So that work, ironically, became part of something that we were speaking to doctors. Now, I want to emphasize to doctors about mitochondrial resuscitation. Became part of a product and program. Mm-hmm. That was picked up by the by the FTC, the Federal Trade Commission. They claimed that an unjustified claim for mitochondrial resuscitation. We then went to the mat with them, and our attorney finally said, "You're not going to win this. There's no way. They don't even understand. Their experts don't even understand nuclear magnetic resonance P31 spectroscopy, and you're going to have to educate the whole FTC. That's not going to go anywhere." So we did a summary judgment, which is what ended me on Quackwatch. That was the entering into my experience with Quackwatch, because now I had a summary judgment of this claim of mitochondrial resuscitation, which that was more than 30 years ago.
Yeah.
But now it's kind of come come good over the years, but that's how things happen.
But now that concept of mitochondrial function is so central in medicine. I mean, again, going back to the new research on the hallmarks of aging, which has only been really developed over the last decade or two because of the investment of a lot of billionaires who don't want to die. And so we're getting all this research that in a field that was completely ignored. And aside from mitochondria, and the microbiome and, many of the things we talk about in functional medicine are part of that. And mitochondrial dysfunction is one of the key features of rapid aging.
Right.
And keeping your mitochondrial health is key. And so it's one of those key concepts in functional medicine that's foundational to treating so many diseases. And now it's emerging with, in mental health, which I think is so exciting around Chris Palmer's work in mitochondrial health. But it's across the spectrum of everything, whether it's diabetes and ketogenic diets or cancer and ketogenic diets. These are all about mitochondrial function. So I think these concepts of gut restoration, of metabolic detoxification, of mitochondrial resuscitation, they're just so fundamental to treating the chronic diseases that we have, and yet they're not something that we learn about in medical school or that's practiced.
Okay, can I say something quickly to that, Mark? And I think you said a really important point. In medical school, you learn about these as esoteric sidebars of unusual conditions that you're probably not likely to see.
Yeah, it's the grunt work you have to go to get the real stuff.
That's right. And so I think probably the most significant contribution that I've made is to say that there's a gradation of effects. At one side, we have pathology, which is where medicine hangs out. That's our diagnostic codes, traditionally over here. And on the other side, we have whatever you want to call wellness. And we maybe have made the assumption that you go from wellness to disease by one-step function. And so, let me give you an example of this. I think it's really important because you talked about insulin resistance. In 1998, the big thing was hypoglycemia. Some of you probably remember that. So there was a oh boy, brings back memories. There was a seminar put on by the University of Washington School of Medicine on hypoglycemia with Dr. Ed Bierman as the leader. I studied out of Dr. Bierman's endocrinology book. He was one of the top endocrinologists. And he invited me to be a presenter. I think I was considered like the fugitive, kind of, they had to have one weird person on the program. So that was me. Now remember, this is 1979, that's a few years ago. And so I really over-prepared. I mean, I knew this was going to be my big chance, right, to say this voice of gradation between normal glycemia and dysglycemia. So I really prepared. I thought, a really compelling argument, which I gave, and I spoke really quickly back in those days. And so I got my information. I was kind of proud of myself, walked out of the stage. Well, Dr. Bierman was the next presenter. So he went up and he said something like, well, this young man was very enthusiastic and he had a lot of interesting things to say, but I want you to know there is no such thing as a gradation between normal glycemia and dysglycemia. You either do or don't have diabetes. There's no ambiguity. So that kind of threw my whole thing out the back door. But I'm very pleased to see that over the years, that has been proven
correct.
I
think that's one of the other big contributions you made, Jeff, is helping us understand insulin resistance, and very early on. And it's still, I just was talking to the folks at Quest Lab, and they said probably less than 1% of the tests done that they get are for measuring insulin. It's still not being checked. It's not being measured. They have a new test that I mentioned called the insulin resistance score, where they look at C-peptide and insulin through mass spec, and it's an extremely sensitive way to pick up insulin resistance. And they're seeing changes and pathology start with a hemoglobin A1C as low as 5.1. So anything over 5 is starting to trend toward a problem, and they're correlating that with lipid dysfunction. So the vision you had to see these things coming decades before anybody else did. I've been measuring insulin in my practice for 25 years. And that's something that every doctor should do. And now with this new insulin resistance score, which is really inexpensive, doctors should be able to actually check whether patients have metabolic dysfunction and insulin resistance, which now affects 93.2% of the population. So lastly, but about 15 minutes left, I want to talk about kind of the work you're doing now around the immune system. And you were one of the first people, again, to talk about inflammation. I remember talking about inflammation, measuring C-reactive protein, again, 25 years ago, before it was even part of the conversation, before I was even really connected to heart disease, connected to cancer, diabetes, dementia, depression, autism, ADD, obviously all the inflammatory diseases like autoimmune disease, asthma, allergy, gut issues, all of it's connected to inflammation. There's this unifying theme. that can mess up the gut, that can cause metabolic dysfunction, that can cause problems with mitochondria. All of it's connected to inflammation. And again, it's one of the hallmarks of aging is inflammation. We typically think of our immune systems as degrading over time. We become less able to fight cancer, more likely to get sick and infections, and that's why we saw this sort of global high rates of death in elderly who had COVID. But you kind of introduced this new idea called immuno-rejuvenation, right? Which is, how do you rejuvenate your immune system? What a concept, right? How do you actually make it work better? How do you bring it back to a more youthful state? And your work around this topic now has been really profound. And then you've connected it all to this concept of immunometabolism. So in the last 15 minutes or so, I'd love you to sort of unpack this whole concept of immunorejuvenation, immunometabolism, and the work you're doing using certain phytochemicals like Himalayan Tartary Buckwheat to actually help the immune system to restore to a more youthful state.
Yeah, I think that again, this concept of our immune system is the revolution of this age. And maybe it was profoundly accelerated because of SARS-CoV-2. We as a country had the poorest outcome of any developed country with the greatest expenditure of medical dollars. We had the poorest outcome, intubation, hospitalization, and death. And it wasn't because we're an older society. It was something was with our immune systems that were not as effective as others. And now we're starting to say it was probably a lot to do with our innate immune system, the first line of defense. That if that didn't do a good job, then things were really passed on to the adaptive immune system, which got overworked. And now people started getting hyper response and hyperinflammation. And so this.
So I'll just stop you there. So for the people listening, the innate immune system is the ancient kind of generalized immune system that is conserved among all species, and it's non-specific. And the adaptive immune system is the one that creates antibodies that are like smart bombs to go targeting the particular pathogen or problem we're seeing.
Yeah, and the innate immune system sits on the surfaces of our outer body that's inside. It sits on our mucosal surfaces of our gut. It sits on our lungs. So it has the first line of defense responsibilities. It's enriched in those places that is exposed to the outside world. And so if it's not working right, then it gives entree into things to get inside and start to act at the second level. So when I started thinking about this and looking at what was going on with research in the immune system, thanks to introductions to people that you introduced me to, like David Furman at Stanford and a variety of others, I recognized that we were starting to learn for the first time how the immune system actually recovers its function when it's undergone insult at the innate immune system level. Because before, it was always thought the immune system was kind of a primitive system that didn't learn, it couldn't be taught new lessons, you couldn't reboot the innate immune system. Well, it turns out that's wrong. We've now learned that the innate immune system can be learned in a different way than the adaptive immune system with its antibodies, but it can be taught, either bad messages or good messages. And so the question is, how do you do that? And then I started studying all sorts of things about the hematopoietic system, looking at where the origin of these cells come from, which is the bone marrow, and what are related to kind of dyscrasias that lead to these immunological problems, and can those things in the bone marrow be rejuvenated? Because these are primordial stem cells, and they have the ability to create different outcomes. All this kind of led me into a swirling study for the last now 5 years, that ultimately, if I can distill it down, to, I think, one salient feature. And that is this family of nutrients that we have neglected importance in nutrition for time historic, which St. Georgie actually brought us to understand. St. Georgie discovered vitamin C, and he got it from what? The reason he was able to discover vitamin C is he was able to amass over a pound of crystalline vitamin C. Remember, he was Polish, or no, he's Hungarian. So what is a food?
Paprika?
Yes. Paprika has the highest level of vitamin C.
I'm winning the trivia quiz today.
Yeah, you're doing well. So paprika was the food that he chose to isolate vitamin C. But what people don't often understand is that when he gave the vitamin C from paprika, the crystalline vitamin C, 99 99% pure crystalline white vitamin C. When he gave it to guinea pigs, remember that's where we get this whole concept of the guinea pig, because it's a vitamin C requiring animal. It can have scurvy. So that was a test organism for antiscorbutic. That's how it got its name, ascorbic acid, ascorbic acid. So when he gave vitamin C to the guinea pigs, they got better, but they didn't get completely well. Only when he gave them the impure vitamin C that had residues of the color of the original vegetable, which he called substance P. He actually called it vitamin P.
For paprika?
Right. And it turns out that that became then known as the anti-permeability factors. So the P played both ways, paprika and permeability. So it prevented capillary fragility, basically, prevented bruising. And it worked with vitamin C. So his view was you had vitamin P and vitamin C work together in a whole food. But we then latched on to ascorbic acid as the be-all and end-all. Well, then you say, well, what is in vitamin P? It turns out it's a mixture of molecules that have color in the flavonoid family. So this kind of got lost over time. It was held on to by the nutrition weirdos, of which I'm proud to say I'm one. And in the nutrition field, the health food field, St. George's work still was around. We still talked about flavonoids with vitamin C. No one else talked about it. It was not in traditional nutrition. Now it's come big time. Now, why has it come big time? There are many, many reasons. I could just go off on this. I promise I'll restrain myself.
Stay on the tracks.
So it was thought, and I think if I surveyed all of you, you would know things about flavonoids, absolutely. Remember the
these are phytochemicals.
Right, they're phytochemicals found in colored fruits and vegetables. So that's why Dr. Minnick says eat the rainbow, because you get a lot of these compounds, these nutrients, in your diet if you eat the rainbow, natural rainbow, not synthetically colored. So it turns out that this array of what we call polyphenols, of which flavonoids are one, that array has huge benefit, we know, as an antioxidant. So everybody talks about the antioxidant effect of flavonoids. Nobody would be surprised in this room me saying it. And I've said it many, many times. As a guy who wrote articles in the 70s on antioxidants, I said it in many articles. Well, that's only a small part of the story, because you cannot in any way, shape, or form correlate the ORAC of flavonoids, meaning their antioxidant capability, with their biological effect. It doesn't correlate. The only thing that correlates is to understand a mechanism of action that is beyond that of their antioxidant. Yes, they are antioxidants, but they're specific in their cell physiology, and they have receptor sites that we're now discovering as signal transducers. They signal to the cell how the genes are going to be expressed. They're the shop bosses that control the genetic architecture of how our genes are expressed, meaning they're epigenetic modulators.
So phytochemicals in foods modify our gene expression.
That's exactly right. Now people say, but if I took all the flavonoids out of the diet, I wouldn't get a deficiency disease. I wouldn't get scurvy, beriberi, plaque, or xerophthalmia, rickets, kwashiorkor, marasmus. So, how do I know that they're useful? We know they're useful because of years of lack of consumption. You will have a rising tide of all chronic diseases that are associated with inflammation.
That's a profound statement, Jeff. What you're saying is that we haven't identified these plant compounds as essential nutrients, like vitamins or minerals. But in fact, they are, and that they don't show up as a, quote, deficiency disease. They show up as a chronic illness later in life.
That's exactly right. So we just finished a clinical trial. When I say we, Dr. Austin Perlmutter is my research director for our little Big Bold Health. We got an IRB-approved study, which I would admit is a pilot study. It's only 50 people, 50 apparently healthy people. We measured their immune epigenome prior to intervention with a polyphenol-rich diet, which turns out to be this Himalayan Tartary Buckwheat crop that we're extraordinarily interested in because it's 4,000-year-old food, and people who live in the blue zones eat these polyphenols that are found in Tartary buckwheat. So,
and the immune genome, for people listening, is basically the genes that regulate our immune system.
That's
and
right.
that turn on or off different
Which
pathways
control inflammation.
that control inflammation or regulate it or upregulate or downregulate inflammation. So this is a really important concept that we have these foods that can modify our immune genome.
Precisely correct. What I'm sharing with you here, I think, is the work of my life. I think this is the most important area I've had the privilege of working in. I don't want to say that we've discovered this. There are many other people that are working in this field. But this clinical trial that we did is quite remarkable. I think it's the only and first clinical trial of its type in which we looked at epigenetic modulation of immune cells before and after intervention after 90 days with Himalayan Tartary Buckwheat polyphenols. And we found 223 differentially modulated CpG sites. What's that mean? It means there were over 200 different genes that we could see over 90 days change their epigenetic regulation of gene expression, which we could correlate with different subpopulations of immune cells. We're actually changing their immune personality over 90 days.
So you're saying basically when you eat these plant compounds like Himalayan Tartary Buckwheat, it has these polyphenols that change gene expression across over 200 genes that modulate inflammation, our immune system, and our immune health?
Yes, and most importantly, and this is the big aha, we did EWAS, epigenetic-wide association studies, on a terabyte of data. So this is a huge amount of information by using AI, machine learning. We found that there was one of these loci that was epigenetically modified 25-fold. This is way beyond statistical significance. This is point many zeros significant. It's ceramide kinase 1 regulatory pathway, which is a dominant pathway controlling immune senescence. We're actually able, with the polyphenols, to regulate one of the central switching genetic controllers of how your immune system ages and transitions itself into meta-inflammation, into basically being in an alarm state.
And aging itself is a state of chronic sterile inflammation.
That's right.
So anything that modulates that is a huge discovery. And what you're basically saying is that we can, through looking at these 200 different sites and the epigenetics, which is essentially the regulator of our genes,
Yes.
we can actually modify how those epigenetic regulation pathways work by taking certain plant compounds that then will upregulate our immune health.
Precisely. And I think the other part of this that to me is,
I'm a pretty good translator, right?
you're fantastic. That's why I need to take you everywhere. You want to travel 6 million more miles?
I'm good. I'm good.
So,
Virtually happy to go.
so the upshot of this to me is as follows. That we know polyphenols have many different names of compounds, quercetin, luteolin, diosmin, I could go down all the names, but just suffice it to say hundreds of different compounds are in this family. And we generally have studied nutrition like we study drugs, one nutrient at a time. So let's study rutin, then let's study quercetin, then let's study epigallate, catechin, gallate, then go down the list. But now what we're learning is that these work as orchestration of regulating genes epigenetically. It's not just one gene at a time. It's not just one molecule against one gene. It is an orchestration. When we eat complexity, we have an effect as you would with a Tchaikovsky suite that's being played by a good orchestra. You don't just have the first violinist. It might be the virtuoso of all violinists, but if you don't have the rest of the brass percussion and woodwinds, it's not going to be the same sound. And so we're finding that this construct of nutrition, whole nutrition, food is medicine, as it relates to the symbiotic, synergistic interrelationship at the genetic regulation level of how our genes express their function, may be the secret sauce that transforms this in all of how we see nutrition.
Yeah. And when you told me you've done studies using the Himalayan Tartary Buckwheat or its extracts to reverse immune age, and that
47% reduction in 90 days
yeah.
with people who had elevated immune age to begin with, 47% reduction in 90 days.
And we're going to be able to increasingly measure these biomarkers clinically and show these interventions and track things over time. I just redid my epigenetic age, and then as I got 2 years older, by applying a lot of these concepts, I've been actually taking Himalayan Tartary Buckwheat, among other things. Even though I got 2 years chronologically older, I got 4 years biologically younger. through epigenetic modulation of these pathways that we can influence through our diet and lifestyle and other interventions. So this is extraordinary work. I think, Jeff, you keep on learning, growing. You're 78 years old, and you act like you're like 25, just discovering, some big thing.
Well, let me just chip in there just quickly. So I'm 78 as of last March, and I also had after all, my own program, my epigenetic immune age measured.
You did function health.
56.7. 56.7. So, we don't know exactly what that means, but as I think, it's much better to be 56.7 than to be 90.
Yeah.
So I think...
and you can measure that through functionhealth.com/Mark, because you get to use their biological age calculator to see what your biological age is. That's what Jeff did. It's pretty impressive. I think anybody who really wants to learn more about this should check out Jeff's work. You can go to bigboldhealth.com, which really Jeff has started as a company to bring this deep science and the understanding of how to apply some of these extraordinary phytochemicals to immuno-rejuvenation. I'm an investor, a supporter. In fact, I put in Himalayan Tartary Buckwheat sprout powder into my smoothie every morning. That's an easy way to get a good dose of it. It's yummy and nutty and delicious. And I think if we can unlock these little nuggets of wisdom that you kind of unpacked for us, from understanding the gut and the microbiome, to metabolic detoxification, to insulin resistance, to mitochondrial health, to immuno-rejuvenation. This is the stuff that is the foundational pieces of the future of medicine. It's going to help lead us out of this desert of chronic disease that we've been wandering in and getting worse for the last 50 years. So Jeff, thank you for your work, for what you do, for what you've taught me, for what you've taught so many millions of people, for the 6 million miles you've traveled around the world, and have a lot of road rash around. I mean, we all wouldn't be here if it weren't for you. So thank you so much, Jeff, for your contribution to the world. And I think Jeff needs to win the Nobel Prize for what he's done.
Well, let me just put it this way. I would be nothing without a translator. So
If you love that last video, you're going to love the next one. Check it out here.